Thanks. So let's get started because this is originally a 45-minute talk that I'm going to have to kind of rush through. So a bit about me. I'm the director of Spider Labs for TrustWave in Asia Pac, which means I basically sit around in meetings and type emails all day. If you're from Australia, you may know me from Sec Talks. You see a lot of references to ducks. That's an Australian kind of in-joke thing, so just try to look through it. So a bit of the motivation behind this talk. So we do a lot of mobile app pen testing at Spider Labs, and we're seeing more and more Swift being used in apps that we test. And obviously, like, fanboys like me, they tend to adopt Apple technology quickly, so all the devs as well, they're starting to move to Swift. I even read that Google is considering using Swift as a first-class language on Android, right? Cats and dogs living together, that kind of thing. I wanted to dive into some of the key differences with Swift and look at the challenges with respect to pen testing Swift apps. So the focus is on black box pen testing of Swift apps. So for a bit more of a lower level, more hardcore RE kind of talk, I recommend a talk that Ryan Stortz did at Infiltrate earlier in the year. It's pretty cool. So how does Swift affect pen testing? So we'll dive into the detail in the rest of the presentation, but the reality is, in most areas, not that much, but in some others, quite a bit, right? So most issues in iOS and OS X apps are due to poor design decisions and misconfiguration, incorrect implementation of Apple and third-party frameworks. So it's not necessarily something that you would have to worry about what language it's written in. But the main thing that has changed with respect to app pen testing with Swift is how you reverse engineer the application. So before we get started, I'll do a quick overview of Swift, just to give you a bit of background. So for those who don't know, Swift is a compiled language created by Apple. It was released a few years ago. It's open source with the official implementations for iOS, OS X, and Linux. And the idea is that it will replace Objective-C eventually. So just some real basic syntax so you guys can follow along. So there's variables and constants, right? So let and var, pretty straightforward. So let is a constant, so mutable value versus a variable. And there's type annotation as well, so you can be explicit with your types. But Swift does infer type. So setting up a class, right? So you've got class and you've got a bunch of variables there or properties there. And you can see the type. The third one there, the owner one, it's a property with a default value of owner. You've got your initialization method in it, and you'll either need to declare all of your variables up front or make sure that they're set in the initializer, so it won't compile if you don't, straightforward kind of stuff. And a class method is just the standard kind of method prefix or keyword is func. If you prefix that with class, it creates a class method. Instance methods, so again, it's just standard func keyword. And you've got here, I guess the one distinction or one thing that I want to point out with this particular one is if you look at the change owner function, it takes a parameter new owner, which is a string. But if you have a look at the isDuck at hack in the box function, you can see there's this duck name in front of it. So that's I guess an exported variable name, right? So the key difference with that is when you call it, and one final thing is the return type, right? There's an arrow and then you put your return type if you need to use a return type. So the key difference with that, and we'll see how it affects the reverse engineering a little bit later, but is you need to actually put that name in front of the variable value that you're using to call it, right? You notice though that when you're initializing it, you still need to put it in there even though you haven't exported the names like we did before, right? So you've just got the normal variables. That's because it's automatically exported for initialization. Cool, so types, so there's all the basic C and Objective-C types, string, booleans, ints, floats, etc. There's a bunch of collection types, array, set, dictionary. There's optional types, works with all types, so there's no more nil pointers like in Objective-C, and Swift is a type-safe language. There's Objective-C interoperability. So it uses the same runtime environment. It still supports C and C++ in the same app. but it can't be called from Swift like Objective-C. So C can't be called directly from Swift, but Objective-C can be called from Swift. Adding this interoperability can allow for some dynamic features in runtime manipulation, which we'll discuss in a moment. Other language features, so there's a bunch of other language features, right? So we've barely scratched the surface. Structs, protocols, extensions, closures, typecasting, generics, all that kind of stuff. Automatic reference counting is in there by default for those that have used that with Objective-C. There's Unicode as well, so that's great. If you're interested in learning a little bit more about the language itself and diving into it, then the Swift programming language book by Apple is really great, and it's free. Cool, so onto the crux of it. So challenges reversing Swift applications. So Swift is less dynamic than Objective-C, so that makes it less flexible in some areas than you would be used to with Objective-C. It can make it harder to do some of the standard tasks that you would typically do on a standard app pen test, and we'll run through what they are and some strategies to get around that. It's less of an issue now because most Swift apps will include Objective-C elements in it. Either they'll drop Swift in as its own module or into a larger app as they're updating it or whatever, or they'll use Objective-C frameworks, which creates that kind of dual runtime, right? So with the interop, which allows a little bit more flexibility. But what we'll see, there's a limited tooling. So if you've done iOS app pen tests or pen testing of OS X apps, there's lots of really cool tooling around it, but obviously with Swift, not a lot of it has been updated, and there's sort of limited tooling directly for Swift. The other challenge is it's rapidly evolving, right? So the APIs and features are constantly being updated. Apple doesn't care too much about breaking changes. With version 4, though, they're starting to look at solidifying the API, right? So it's going to be less breaking. But if you just have a look just over the last couple of years, there's been a lot of updates in Swift. So it can make it a bit of a challenge, trying to keep up with everything. Cool. So there's two primary reverse engineering activities when you're doing a black box pen test, right? And by black box, I mean you don't have access to source. So the first one really is dumping and analyzing class information from the binary, so you can get an understanding of what makes up the app and where some potential vulnerabilities might be, and then retrieving information at runtime using like debuggers, function hooking, tracing, things like that. So first step, and often the most important step on an iOS or an OS X, but I guess I focus on iOS a little bit. Pen test is retrieving class information, right? So the most common and easiest way to retrieve it from Objective-C applications is with the class dump utility. Anybody who's done a iOS pen test would know class dump. So it retrieves class information and formats it to look like the equivalent of an Objective-C header file, right? So for those who haven't used it, and we'll go into sort of what it looks like in a minute. And it's usually one of the first things you do if you're looking at an app, right? Just to get an understanding of how it works, get some more insight into the makeup of the app and some of the functions and methods that are in there. So this is what it normally looks like, right? And this was just a Tweetbot on my Mac, and just a class that I took out of the class dump, right? So pretty standard kind of, it looks like a header file, right? So you've got your interface, declaration, and you've got your class, your superclass, you've got your properties and instance variables, and you've got your class and instance methods there. And then you can see there's arguments as well that get passed into it. But what happens when you run class dump on a pure Swift binary? You get that. That's all you get. So wow, right? So we need to look at something else. So yes, class dump C doesn't work with Swift binary, so now what? So let's start looking at the binary itself. So what do we get if we dump the symbol table? So we get a bunch of interesting stuff, right? It looks like there's some stuff there. So if we look for something that we know is in the binary, so this print duck type method, you can see that it's showing up, right? So okay, there's something there that we could potentially use. So it looks promising, but it's a bit of a far cry from the neatly formatted output of class dump, right? So the reason it looks a bit odd is that Swift stores metadata about a function and its symbols, and it sort of mangles the name by adding all this metadata. So if we deconstruct the mangled name a little bit, so the first element, the __ t indicates that it's a Swift method. The F indicates that it's a function. The C indicates that it's a function of a class. Pretty straightforward. Then you have the module name prefixed with the length of that module name. The class name prefixed with the length. And the function name also prefixed with the length. That's a function attribute, and it can change. I'll go through different function attributes that you can have. Then you have parameters. This particular method doesn't have any parameters, so there's nothing there. And then you have your return type at the end. Again, this didn't have any return type. Cool, so there's various function attributes. So f is just your standard normal function. Lowercase s and g for your setter and getter methods. Lowercase d and c for your destructor and constructor methods. And capital D and C for your deallocator and allocator methods. Return type, so all your standard kind of stuff there. So arrays, booleans, doubles, floats, integers, strings, the works. So that's all the different types that you can potentially have. Now we know roughly how those names are constructed and how they're mangled. You could use that information to do mangle names, right? The good thing is Apple's already included a little utility called Swift to Mangle to do just that. So if you have a look at the output of Swift to Mangle, there's a few options. The first one is just running it and piping in or giving it a mangled symbol name. And you get on the right side, if you see, hang on, I'll use this pointer. If you have a look on the right side, you get a demangled output there. There's a few other options that are interesting. So compact takes away that stuff at the front where it has the sort of the mangled name with the arrow. And then simplified as well takes away the module name, so you're just left with the class and the method name and then any parameters and your return type if there's anything. But you can also use the expand option, and it'll give you a whole bunch of information expanded out. So this is useful, right? So if we're just using like NM and Swift to Mangle, the other thing as well, for those who want to try and run this, this is something that you need to pass into XC_run. So it's part of the Xcode utility. So it's XC_run Swift to Mangle. I've just set up an alias, so that's why I've only got Swift to Mangle. Cool. So you can, with some shell scripting, right, you could create something that would easily grab the function signatures in the app, and it should be all that you need to basically get similar information from class dump to start assessing the app. So I've hacked together a script or a little app, I suppose, that demangles names and formats it in a way that approximates the output of class dump. It's written in Swift because why not, right? I'll give a little bit of a demo of how that works. Cool. So I just called it class dump s because why not? And this is the same app that we had before. Maybe if I can. Cool. So we'll go back up to our class that we know. I think it's up the front here. Cool. So we've got our duck class, right? And we've got the methods there. Change owner, which takes a string. It doesn't have the parameter names in the class in this sort of class dump unless you've exported it, right? So that's why it's showing this duck name there. So that's a little bit of a tricky thing if you need to get that kind of information. For example, if you're trying to call this directly, you want to know the full function signature. One of the good things though about like Swift and generally any Apple kind of coding is that it's all these sort of names and variable names and function names are generally pretty verbose, right, and pretty descriptive. So what you'll see is like this kind of pattern of function with whatever, and the first like with name, and then the first parameter will be name, right? So you can kind of start constructing it, potentially with just using some of those sort of conventions. Cool. So, I mean, the obvious caveat with this, right? So if the developer strips symbols from the binary, these techniques obviously won't work. Reverse engineering stripped binaries is a little bit more complicated. I don't have enough time to go into too much. One of the things I'll be working on with the tool is to kind of, have some techniques to get in, extract that information, or as much of that information as possible, if you are working with a stripped binary. But obviously, if you've got symbols in there, then you want to use as much information as you can get, and that's sort of where we're at the moment with the tool. So Objective-C compatibility. So how does this kind of shift things up? So part of the reason why it's much easier to get class information from Objective-C is because it's necessary for the Objective-C runtime to have that information for it to run, right? So what happens when you import Objective-C frameworks or use Objective-C in your app? So with that in mind, let's revisit ClassDump. So the latest branch of ClassDump by Steve Nygaard, which is the original ClassDump utility, has some limited support for Swift. You need to download it and build from source. So if you go to the GitHub page, you can't go to the releases and download a binary, but you can just build it from source in Xcode. So yeah, another contrived class here with just a few functions and a variable there, property there. If you try to do that, you get this, right? Error passing type. So no luck. But if we make a very tiny change, we'll see how it changes. So I don't know, has anybody spotted the change from the previous one? All right, so just included this NSObject, right? So now the hack-in-the-box class is inheriting from NSObject, which is an Objective-C class. And yay, here we go. So that works, right? Because now you're mixing the two, and there's and it's obviously putting that information in there, and it's allowing us to get that information from the binary. So it's not the greatest, so there's still some sort of issues there, but it's definitely worthwhile if you're maybe working with a binary with stripped symbols, or you can't get it any other way. But it's good to know that that's there. The good news with that is that for the time being, it's likely that this will be possible because until we have all the frameworks written in Swift, you're always going to have this mixed environment. Cool. So there's other options. So obviously you can fire it up in a disassembler, so Hopper, IDA, whatever. It's necessary for lower level insight into how the app works. And you will still see all the demangled symbol names for the function names. But there is some scripts, so I've just included some for Hopper because that's what I use mostly. But there's also, I'm sure there's plugins for IDA and other things as well that will demangle those names, those symbols, so you can get proper function names. So function hooking. Okay, we're not doing too bad. So hooking Swift methods. So it's still possible. It's much easier in mixed Swift Objective-C and Swift and Objective-C binaries, and you can still write tweaks with mobile substrate. So if you take a very simple class and method, you've got the class here with a property, how great is hack in the box, and the initializer is setting it to 5, but hack in the box is great, so we want to change that and maybe make it more, right? So there's a few ways you can do it. So you could hook the getter method, and that works. So this is basically just hooking the getter method and making sure that it returns 10. You can hook the setter method, which kind of works. So the set how great is hack in the box. That kind of works. Where it falls down is certain functions in Swift are inlined, and the class constructor is one of them. So init, so this is what that's what we saw here, init. And that's what's setting the instance variables. So in this case, the setter will only be called again by the top level code. So if it's called from there, the hook works. But if it's not, well, then you won't get the new value. Cool. And then you can change the instance variable directly. That works. but it's usually not a good idea because it might mess up the way that the application works. But if you have a good understanding of how the application works, this is another method that you could use potentially to hook into Swift and do some stuff. Cool. So wrap up. I've done that even quicker than I thought I would. Cool. So I guess the final kind of takeaway is that not all hope is lost when it comes to your standard pen test workflows with Swift apps, right? So you're used to doing iOS app testing, let's say, for your job, and you get hit with a Swift app and you don't have any source code. There's still stuff that you can do. It's still a bit more of a pain in the ass with Swift apps, like pure Swift apps, if you don't have access to the source code. But at least there's some possibility for your standard kind of workflows. And as I sort of said earlier in the presentation, most issues in iOS and OS X apps are due to poor design decisions or misconfiguration and incorrect implementation of frameworks and libraries. So again, a lot of what you're going to look at doesn't necessarily, is not necessarily impacted by whether it's a Swift app or an Objective-C app. So if the developer's not securing sensitive information, they're not securing information as it goes over the wire, that kind of stuff, not really dictated by whether it's written in Swift or Objective-C. So definitely something where there's still a lot of stuff that you can look at and a lot of stuff that you can do. Cool, so next steps. So I want to improve the class dump S script. Some of the limitations at the moment are that it's OS X specific because it shells out to Swift to Mangle, which I don't like anyway. So probably maybe implement some kind of demangling logic within the script itself. And then, as I said, it's relying on being able to access these symbols easily. So I want to update the script so that it could potentially be used in cases where that information is not as easily accessible. And sort of have it so that if we've got certain information, we'll be able to present it. But if we've got limited information, we'll be able to at least extract that in a nice way. I was going to go into sort of runtime inspection, but this is only a very short talk, so I unfortunately ran out of time. But just to give a bit of a summary of some of that, so script works, but it's not as straightforward as working with Objective-C. And I guess also this will depend on whether this is a pure Swift binary or whether it's a mixed binary. LLDB works well if you're familiar with it. That's pretty standard kind of debugger. There's a lot of great Apple tools as well that will help when it comes to debugging these applications. And hopefully I'll write a bit of a blog post on it as well. Cool. So I think it's everything. I wrapped up a lot quicker than I thought I would, so it's good. Any questions?
Thank you, Michael. Thank you, Michael. So any questions from the floor?
I'll be hanging around, so if you think of one, come see me. It's fine.